Hello everyone. Today we shall discuss few more important questions of DMS. Okay. See here, there is a tree is being given. The question is find out the minimum cost spanning tree. Okay. So before going to that, we shall study what is tree first. Tree means what? It is an undirected graph in which all the vertices are connected. For example, okay. See, what is this? This is called as tree. And all these are called as vertices, or you can say endpoints. And these are nothing but the edges. So, it is an undirected graph. Okay. See here, and this graph is symbolized as G of VE, where V is the vertices and E are the edges. Okay. In the tree, what is a spanning tree? Spanning tree means here also all the vertices are connected but without forming a circuit, means there is no closed path. For example, consider the vertices 1, 2, 3, 4. Okay, if I join on the vertices like this, then this is not a spanning tree. Why? Because all the vertices are connected here. They make a closed loop here. Okay, so then what is spanning tree? Okay, so this we can call as a spanning tree. Why? Because there is no closed loop or closed circuit. Okay, so this is the meaning of spanning tree. Now find the minimum cost spanning tree. There are two algorithms to find out the minimum cost spanning tree. The first one is Prim's algorithm, okay, and the second one is Kruskal's algorithms. Okay, now we shall study these two algorithms. Let us study the Prim's algorithm. Prim's algorithm of finding the minimum cost spanning tree. So according to Prim's algorithm, first we have to consider the edge which is having the lowest cost. See here, totally how many edges are there? Sorry, not edges, vertices. 1, 2, 3, 4, 5, 6, 7. So here the total number of vertices is 7, and the edges we require for a spanning tree is the thing but vertices minus 1. Okay, means it has to have the number of vertices minus 1 number of edges. Therefore, vertices 7 minus 1, that is 6. To make a spanning tree, we are supposed to have 7 vertices and 6 edges. Now, see here the cost, or you can say weightage is being given already between the vertices 1 to 28, 16, 12, 18, like that different cost or weightage is given. Now, among these we have to consider the edge which is having the lowest cost. So consider which is having the lowest cost here. Among all these, 10 is having the lowest cost. Consider that edge first. It is in between vertices 1 and 6. So this is 10. This is step 1. Now the next one. Okay. See here we have two vertices 1 and 6. 1, consider 1 is connected to 2 and the weightage is 28. Whereas 6 is connected to 25 where the weightage is 25. So out of 25 and 28, which is the lowest one? 25. So we have to consider this now. So 6 to 5. 6 to 5 and the weightage is 25. Now the next one. Consider 6 is over. 6 was connected only to 1 and 5 and that is over. Now consider only 1 and 5. 1 is connected to with the weightage 28. 5 is connected to 7 with weightage 24 and 22. So among 22, 24, 28, which is the lowest? 22. So consider this one. 5 is connected to 4 with a cost of 22. Okay. Now the next one. 5, 1, 4 we have. Again 1 is connected to 2 with cost 28. 5 is connected to 7, okay, with the cost 24. Whereas 4 is connected to 3 with the cost 12. So among 12, okay, 18, because 4 is connected here. 4 is connected to 7 as well as 3. 18, 12 and 28, which is having the lowest cost, that is 12. So 4 is connected to 3 with the cost 12. So how many edges are over now? 1, 2, 3, 4. So we need 2 more. Now coming to 3. 3 is connected here. Okay, this is over. 3 is connected to 2 with the cost 16. Okay, whereas 5, 24, 16 and 28. Out of these, again this is the lowest. Therefore, 3 is connected to 2 with the cost 16. Okay, how many edges now? 1, 2, 3, 4, 5. One more we need. Now, 7 we want as usual, because all the 6 edges are covered now, only 7 is left. Now see, where from where we need to connect to 7. See, from 5 we can connect, the cost is 24 from 5. Okay, next from 2 it is 14, from 4 it is 18. Now which is the lowest among these 3? 14 is the lowest. Therefore 2 is connected to 7 and the cost is 14. Now see, according to the spanning tree concept. What is spanning tree concept? It must have all the vertices, but there should not be any closed circuit. So here is no closed circuit. According to Prim's algorithm, the number of vertices must remain as it is, 1 to 6, 7, and the edges must be one number less than the number of vertices. Therefore, see here, 7 vertices and edges how many? 1, 2, 3, 4, 5, 6. So now what is the cost? Cost of this tree. We need to add all the costs here. See, 10, 25, 22, 12, 16 and 14. So the total is 99. Okay. See, this is the what? Minimum cost spanning tree using the Prim's algorithm. See, this is the exact answer. But if this question is asked for 5 marks or 10 marks, you are not supposed to write like this. You need to write this in the form of steps. That I will explain you now. Now, the same question, the same answer, but for 5 to 10 marks answer, we need to write the same answer in terms of steps. Okay. So now, step 1. So, consider all the vertices. So, you just need to put only the vertices here. So, this is step 1. Okay. Now, step 2. Step 2 will be, we have to consider one starting point. Of course, the starting point will be with the minimum cost edge. Okay. So, starting point should be 1 then. So, now consider the starting point as node 1. So now when we consider the node 1, we have to consider which are the edges connected to the node 1. So, out of them, we have to consider minimum of. See, 1 is connected where? To 6. Next, 1 is connected to 2. Over only 2. 1 is connected to 6 and 1 is connected to 2. Out of these two, we have to find out the minimum. So, minimum of 1, 6 and 1, 2. Now, next, minimum of 1, 6. What is the cost? That we need to write here. 10, comma. 1, 2. The cost is 28. So, now we got the weightage or the cost. Now, the minimum will be 10. Okay. Therefore, consider the edge. Which edge now? 6. So, the second step will be like this. So, this is our second step. Means the whole scenario I am explaining in step by step now. Okay, second step is over. Now, the third step. Now, as we have two vertices here, 1 and 6. Okay, 1 can be connected and 6 also can be connected. Now, we have to find out minimum. Minimum of, okay, so here, 1. Where this 1 can be connected? 2. 1, 2. Okay, 1 is over. 1 is already connected to 6. The only left is 1, 2. Now, 6. Where the 6 is connected? 6, 5. This is also over. Now, minimum of 1, 2 cost is 28. 6, 5 cost is 25. Okay, so now out of 28 and 25, the minimum is 25. So in this step, we need to connect 6 to 5. Okay, so that will be like this. One to 2 is, sorry, 1 to 6 is already connected in the step 2. Now in the step 3, we need to connect 6 to 5. Okay, now what will be the step 4? That I will write here. So, in the step 4, we are having the edges 5 and 1. Okay, so again, minimum of 1 can be connected to 2 and this 5 can be connected to either 4 or 7. So, 5, 4 and 5, 7. In that case, minimum of 1 to weightage is 28. 5, 4 is 22 and 5, 7 is 24. So now out of these 22 is the minimum cost. Therefore, in this step, which edge is considered here? 22. So that is nothing but 4. Okay. So in the step 2, 1, 6 is connected. Then next 6 to 5 is connected. Now 5 to 4 is connected. Okay. Next step 5. Now we are having edge 1, okay, and 4, then 5. Okay. These 3 vertices we need to consider now. So here minimum of 1, 2, then 5, 7, then 4, 3. Now, minimum of 1 to 8 age is 28, 5, 7 is 24, and 4, 3 is 12. So again we need to consider the lowest cost, that is 12. So in this step, the vertex 3 is considered. So here 1, 6, 6, 5, 5, 4, and now 4 to 3. Okay. So in the next step, automatically we will get 3 to 2 and 2 to 7. Okay. So this is how we are going to get the minimum cost spanning tree using the Prim's algorithm. So again the cost will be as usual 99. Okay. So it is very simple, but the thing is you have to follow the steps properly. Okay. Now the next algorithm, that is Kruskal's algorithm. This algorithm is also used to find out the minimum cost spanning tree. Okay. See here, the method is quite simple compared to the Prim's algorithm. Here we need to consider only the minimum cost edges. Okay. Now, the first one, the lowest one, that is 10. Consider that one. 1, 2, 6. 10. Next, after 10, which one comes? 12. Okay, so here is. Next, after 12, we have 14. After 14, we have 16. After 16, okay, which one is there? That is 18, right? Now see, if I connect this edge, what it becomes? We will have one closed loop, which we are not supposed to have according to the spanning tree concept. So we must neglect this. Okay. Now after this, 18. Next one is 22. From 4 to 5. 22. And as usual, remember the number of vertices is 7. That means the number of edges must be 1 less than that. So 6 edges we must have. Now already how many we have? 1, 2, 3, 4, 5. So one more we have to have. Okay. Now see here, all the vertices are covered. Now the next one is, this cannot be a different from this one. So we need to connect 5 and 6, and that is 25. Okay. So this is how we are having one spanning tree, minimum cost spanning tree. Okay. So here, what is the cost? Okay. So cost is, again add all these. So again the cost will be 99. So what is the difference between Prim's algorithm and Kruskal's algorithm? In the Prim's algorithm, we take only the minimum cost edge. Later we start considering the connectives. Whereas here we need to consider only the lowest cost edges. Later we need to connect them. So this is the only difference between Prim's algorithm and Kruskal's algorithm.